Dr. Tom McNamara back again for our course in trigonometry. In this video, I want to introduce the concept of an inverse trig function. And once again, I'm using the document camera because our calculator will be helpful for this task. So I'm just going to do a little scheme here. Now typically, when you're working with trigonometry, you start with an angle and you get a ratio. And remember, the general concept of a function is you take an element of the domain and you follow some kind of rule, and it matches up with an element in the range. So for a trig function, the elements of the domain, in other words, the input values of the function, are angles, and we figure out how to get a ratio, either by starting with an angle in standard position in the xy plane, or setting up a right triangle. Well, in mathematics, we're also concerned with going the other way. This is called the inverse process. Okay, so your trig function takes an angle, gives you a ratio. The inverse process takes a ratio and gives you an angle. Okay, so let's do one or two of these here to get a feel for what's going on. So let's do examples. Find an angle A with 0 degrees less than or equal to our angle A less than 90. Okay, so in other words, an acute angle, so that, and for this first one, let's say we want tangent A to be equal to 2.5129. Okay, so we are given the output from the tangent function, and we want to know the input that would make this happen. Alright, so you'll notice on your calculator here you have your buttons for sine, your cosine, your tangent, and you'll notice above them it has the same term except there's a little -1. Okay, that's the inverse function, and all of the buttons on this calculator have two things that they do. The main thing that they do is when you just hit the button. The alternate function of the button is when you hit the second key and then hit the button. So here's what I'm going to do. I'm going to enter 2.5129, and then I'm going to hit the second key. So notice it even lights up right there. Then I'm going to hit the tangent key, and it's saying 68.3. Okay, so A is approximately 68.3 degrees. Now, I should be able to take the tangent and get right back to where I was. Okay, that's the whole point. If I take the tangent of 68.23, I get this target output. Okay, so that is our first example of working with an inverse function. Let's do another one right away. Let's say we want to find an angle A such that sine A equals 0.63, 6032. Okay, I want to find an angle A such that sine A equals 6.032. So once again, I'm going to use the inverse trig functions on my calculator. In fact, let me show you with this other calculator. If you have a multi-line display, you can enter it a little differently. Okay, so with these old-fashioned scientific calculators, I have to enter the input first, then hit the trig function button. With this multi-line display calculator, here's what I do. So I'd like to see both of these. Okay, so great. So here's what I'm going to do. I'm going to hit my second key first. Then I hit my, let me clear things out here. So hit my second key, sine. Okay, so now I've got the sine with that exponent of -1. And that exponent of -1 just indicates that we're doing the inverse. And now I put 0.6032 as the input. Whoops, I put a little minus there. It should be a decimal point, not a little minus. Okay, so sine inverse of 0.6032. I press the enter key. It'll do a computation, and it tells me that my angle A is approximately 37.1 degrees. And just to check, if I take the sine of 37.09 degrees, it should give me something pretty darn close to 0.6032, 0.603. Okay, we're pretty good there. Okay, so remember, ordinarily, when we're working with trigonometry, we take an angle, we get the ratio. There are times we will need to work backwards in this course. We'll have the output from the trig function, and we'll need to go get the angle that would produce that output. And that's where the inverse trig functions come into play. Okay, there's one more type of example that I would like to work on. Okay, so I want to find an angle A such that the cosecant of this angle is equal to 1.0338. All right, now, here's the problem, okay? I look on my calculator, I got buttons for sine and sine inverse, cosine, cosine inverse, tangent, tangent inverse. I don't got a button for cosecant, but we have our trig identities. Okay, so we know that the cosecant function is related to the sine function, and they are reciprocals of each other. If I know the sine, I do 1 over sine and I can get cosecant, and that relationship works both ways. If I know the cosecant, I can take the reciprocal of that and get the sine. So this is telling me that sine A is equal to 1 over 1.0338. I take the reciprocal of this number right here. Now, on my calculator, there's a very quick way to do that. So I can enter the 1.0338, and then there's a reciprocal button right there. So hit that. So it tells me the reciprocal is 0.967, blah, blah, blah. And now I'm going to take sine inverse using my second key. And it's giving me 75.3. Okay, so my angle A should be approximately 75.31 degrees. Okay, the instructions for the problem will tell you how many decimal places of accuracy you're expected to give for this. Okay, and you can always check your answer. Okay, if I take this angle, and then I take the sine, and now I take the reciprocal of that, notice what I get. Okay, so when you're doing these inverse trig functions, you can always check your answer. If you're looking for an angle whose cosecant is 1.0338, and you get this at the end, well, take the cosecant of this angle. How do you find cosecant with your calculator? Well, take the sine and do the reciprocal. Okay, so these inverse trig functions, you start with the ratio and you can work backwards to get the angle. Okay, that'll be pretty important for some applications that we do later in the course.